Most volcanoes and earthquakes are caused by the motion and interaction of Earth's plates. How the location of volcanoes and earthquake epicenters are related to tectonic plate boundaries? I will answer that question in today's video. Hi, and welcome back. Earthquakes, volcanoes, and plate tectonics. Where volcanoes form. A plot of the location of plate boundaries and volcanoes on Earth shows that most volcanoes form along plate boundaries. As you can see in the map, Earth's lithosphere is divided into about 13 major plates, where plates collide, separate, and slip past one another. Interesting geological activity results. As you can see in the map, how this indicates that plate tectonics and volcanic activity are related? Perhaps the energy involved in plate tectonics is causing magma to form deep under Earth's surface. Plate movement often explains why volcanoes form in certain areas. Divergent plate boundaries. Tectonic plates move apart at divergent plate boundaries. As the plates separate, long cracks called rifts form between them. Rifts contain fractures that serve as passageways for magma originating in the mantle. Rift zones account for most of the places where lava flows onto Earth's surface. Fissure eruptions often occur along rift zones. These eruptions form lava that cools and solidifies into basalt, the most abundant type of rock in Earth's crust. Convergent plate boundaries. A common location for volcanoes to form is along convergent plate boundaries. More dense oceanic plates sink beneath less dense plates that they'll collide with. These set up conditions that form volcanoes. When one plate sinks beneath another, basalt and sediment on an oceanic plate move down into the mantle. Water from the sediment and altered basalt lowers the melting point of the surrounding rock. Heat in the mantle causes part of the sinking plate and overlying mantle to melt. This melted material then is forced upward. Volcanoes have formed in this way all around the Pacific Ocean, where the Pacific Plate, among others, collides with several other plates. This belt of volcanoes surrounding the Pacific Ocean is called the Pacific Ring of Fire, that you can see here in this illustration. Hotspots. The Hawaiian Islands are volcanic islands that have not formed along a plate boundary. In fact, they are located well within the Pacific Plate. What process causes them to form? Large bodies of magma called hotspots are forced upward through Earth's mantle and crust. Scientists suggest that this is what is occurring at a hotspot that exists under the present location of Hawaii. Volcanoes on Earth usually form along rift zones, subduction zones, where one plate sinks beneath another, or over hotspots. At each of these locations, magma from deep within Earth is forced upward toward the surface. Lava breaks through and flows out, where it piles up into layers or forms a volcanic cone. Moving plates cause earthquakes. Earthquakes often occur where tectonic plates come together at a convergent boundary, where tectonic plates move apart at a divergent boundary, where tectonic plates green past each other called a transform boundary. Earthquake locations. If you look at a map of earthquakes, like the one in this picture, you'll see that most occur in well-known belts. About 80% of them occur in the Pacific Ring of Fire, the same belt in which many of Earth's volcanoes occur. Earth plates and interior. Researchers have learned much about Earth's interior and plate tectonics by studying seismic waves. The way in which seismic waves pass through a material depends on the properties of that material. Seismic wave speeds and how they travel through different levels in the interior have allowed scientists to map out the major layers on Earth. For example, the atmosphere was discovered when seismologists noted the seismic waves slow when they reached the base of the lithosphere of the Earth. These partially molten layers forms a warmer, softer layer over which the colder, brittle rock plates move. What is driving Earth plates? There are several hypotheses about where all the energy comes from to power the movement of Earth's plates. In one case, mantle material deep inside Earth is heated by Earth's core. This hot, less dense rock material is forced toward the surface. The hotter rising mantle material eventually cools. The cooler material then sinks into the mantle toward Earth's core, completing the convection current. Convection currents inside Earth, shown in the fissure, provide the mechanism for plate motion, which then produces the conditions that causes volcanoes and earthquakes. Sometimes magma is forced up directly within a plate. Volcanic activity in Yellowstone National Park is caused by a hot spot beneath the North American plate. Such hot spots might be related to larger scale convection in Earth's mantle. I hope you found this video useful. Thanks for watching and until the next one. Bye!